All right, an example one here, we're simplifying expressions with the product property. Okay, so here you just have to be careful, especially when doing your homework. Anytime we have an odd, we got to be careful. We might have to use absolute value. But this right here is non-on. There's actually kind of like a 2 there, right? Because it's a square root. So since this first one is odd, we can separate this to the cube root of negative 27, which anytime you get a cube root of negative, you're just going to get negative answer, right? So the cube root of 27 breaks that down to groups of 3. So 3 times 9, and then 9 is 3 and 3, so a group of 3. So it just comes negative 3 on the outside. Okay, and then on the rest, we have a cube root of a to the 6th and b to the 14th. So we can just rewrite these as, we can just rewrite these as fractional exponents. So a to the 6 over 3 and b to the 14 over 3 as well. So we just reduce these evenly. So 6 divided by 3 is 2. So this would be a squared on the outside because it comes out evenly, right? I just have 6 a's. And I have groups of 3, 1 group of 3, 2 groups of 3. So a squared is on the outside, right? Groups of 3 I'm looking for. Okay, b to the 14th, how many times does 3 go into 14 evenly? That'd be 4 with the remainder of 2, right? So it goes in 4 times, so that means b to the 4th is going to be on the outside. Okay, and then on the inside is just going to be a remainder of 2, so that means I stay a cube root on the inside, and that would be b squared, that remainder. Okay, and I did say at the beginning, anytime it's odd, I have to be careful, but actually odds are fine. It's the evens ones that I got to watch out for. So sorry, this is the end answer. I'm done there. Anytime it's odd, it's okay. Evens, that's when we're going to look out for these. So I can do the square root of 75, which it's not top off of my head, but I can break down, look for pairs, 25 and 3, and then 25 is 5 and 5, so there's a group of 5, so that goes on the outside, right? And then that 3 stays on the inside, so the square root of that 3 has no pair, so it stays on the inside. Now I can break down the square root of x to the 12th. So I have 12 x's, so how many groups of 2 are in it? Same with y's. Y's to the 7th, I have 7 y's. How many groups of 2 are in 7? So really that's the same thing as saying x 12 over 2, and x is, or y, sorry, y 7 over 2. So x 12 over 2 goes in evenly 6 times, right? So I have a group of 6 with no remainder. And then 7 goes in evenly 3 times, so y to the 3rd, and I have a remainder of 1, correct? So that 1y would stay in here, y to the 1st. Okay, now anytime I have even and I have an odd type of exponent, that means that needs to be surrounded in absolute values. So y to the 3rd, an odd exponent as an answer to an even root, I need to put in absolute values. Okay, so that's kind of the trick with it. If you have 2 of them, say it was x to the 5th, y to the 3rd, then I can just surround them like that together, an absolute value. Okay.